Okay, in this mini lecture, I'm going to work through the calculation of the chi-square test of independence. And this is a set of tables that we work with in class one day. Let me take you back to the output just for a second and remind you that the computer gives us the chi-square value. In this instance here, it was 4.453, okay? The computer gives us the chi-square value. It also gives us the degrees of freedom and the p-value. So when we're using SPSS or Megastat or SAS or Minitab, we don't need to calculate the chi-square value ourselves. However, I want you to conceptually understand the chi-square value so that you can understand what is it that causes one set of data to have a large chi-square and another set of data to have a small chi-square. So keep in mind here, the chi-square value for this particular data was 4.453. Alrighty. Now you'll recognize this data. This is what we started out with originally. Alrighty. And then we build a table of expected values. And by the way, if you see these little red tags, I've put notes in throughout this to show you what's going on or what the calculus. So this says each cell is calculated as the row total times the column total divided by the grand total. Okay, let me repeat that. The row total times the column total divided by the grand total. So the expected value for 19.48, that's equal to 57, the column total, times 41, the row total, divided by 120, the grand total. So if you take 57 times 41 divided by 120, that equals 19.48. Okay, cell 22 here, single people who do not drive a sports car, this 41.48 value is 63 times 79 divided by 120. And if you move your cursor over the little red tag, it says this is calculated as 63 times 70 divided by 120. Okay, so the calculations here should be a trivial action for you. Then you see this O sub I minus E sub I. This is the observed value for a particular cell minus the expected value for a particular cell. So let's take cell 1,1 where we get minus 5.48. Okay, so O sub I is 14, E sub I is 19.48. So 14 minus 19.48 is minus 5.48. Okay, and if you look at the cursor here, it says I typed in this is obtained by subtracting 19.48 in the prior table from 14 in the first table. Okay, so doing this calculation for the tables here is not at all difficult. But notice here, anytime we sum our deviations, it always comes to 0. Okay, I mean you learned that back at the beginning of the semester when we learned how to calculate the variance and the standard deviations. And here we do the same thing as we did earlier in the semester when we calculated standard deviation, is we square our deviations. So since minus 5.48 plus 5.48 sums to 0, okay, we square minus 5.48 and we get 29.98. And since every value in this table is equal to 5.48 in an absolute value sense, when you square every cell here, you get 29.98 in all 4 cells. So that sums to 119.9. Okay? All right. And again, you can look at the cursor here and it tells every value in this cell, not the margins, but in the actual data itself, is simply the corresponding the corresponding number squared from the prior cell. I need to fix the wording there. All righty. So calculating the expected values, no big deal. Calculating the deviations, no big deal. Calculating the squared deviations, no big deal. And this is the closest that you're going to get to complicated arithmetic, where here we take our squared deviations in each cell and we divide them by the expected value for that cell. Okay? So if you take 1.54, let's see if I can get all this on one screen here. If you take 1.54, you take 1.54. I'm not quite. Let me take a row out here. That should let it fit. Okay, so this 1.54 here, that's equal to 29.98 divided by 19.48. This value of 1.39 right here, that's equal to 29.98, the deviation squared, divided by 21.53, the expected value for that cell. Okay. 0.80 is equal to 29.98, our squared deviation, divided by 37.53. So again, calculating these is no big deal, but here's what becomes relevant. Okay, when you sum the rows or when you sum the columns, that gives you your chi-square value. Okay, that gives you your chi-square value. So when we see the chi-square value on our output, 4.45, okay, you might say, well, how did the computer program come up with that? You simply follow this process right here. You simply follow this process. You start out with your original data. You eventually end up down here. Okay, that value in the bottom right-hand corner, that's your chi-square value. Okay, that's your chi-square value. So what you then can see is which cells contribute most or least to the 4.45. And what you see here is these two cells happen to be of the four cells, cell 1,1 and cell 1,2 contribute more to creating the chi-square value than the other two cells. Okay? Thank you.